clean data, this is a step that we always have to do. And unfortunately, a lot of stats classes just kind of ignore it like it didn't happen or isn't necessary. Cleaning the data can take half the time of data analysis. And I always include it even just a little bit so you remember that we need to do this. So note that we have several missing values in our data, right? We already saw that when we looked at the sex in the summary. We saw we had 11 missing values, right? This can muck up our graphs and analyses later on. So it's best to clean up our data and remove them now. Really, the order of events is important. You don't put the pasta in and then add the cold water and then bring it to a boil. You'll have gooey pasta, right? You got to bring the water to a boil and then you add the pasta. So you got to clean your data and then do your analysis. If you do your analysis and then you realize you've got problems, then you go back and do your data cleaning, then you have to go back and do your analysis. It just takes you more time. So just clean it first. Clean your room. Clean your room. Clean your data. Let's take a closer look at our data and see where the missing values are. So I just put this little snippet of code in here to get the column names with the NA values and the count. So this just gives us each data, each variable, and says how many NAs are in each of them. So species island, they've got a, they always knew what species they were looking at. They always knew what island they were on. Good. They missed the bill length and the bill depth on a couple of them, as well as the flipper length and the body mass. And for sex, there was 11 they didn't know. They always did know the year, so they always got the year recorded, but 11 missing on the sex. I'm thinking it's probably just hard to tell. Maybe it's hard to tell with penguins, like with parrots, you can hardly tell. Anyway, so we can see that sex has 11 missing values. So let's remove the NAs from the data. Now, remember, this is really important because when you do this step of NA omit on the whole data set, it will go through and remove where you have NAs in any of your fields. So if you have a field, like let's say they didn't record island for a whole bunch of them. Well, we're not going to analyze island. So if you remove NA from the island variable, you also remove all those records from everything else, right? We would lose a bunch of data. So that's why sometimes we actually select the variables of interest and then do the NA omit. But in this case, we're going to just try doing NA omit on the whole data set and see what happens. And I'll show you it works out because I did it ahead of time, All right, it's always essential to check that this will only remove the NAs for the data we want to analyze. So we don't remove rows with good data because there are NAs in variables we will not use in our analysis, right? What I just told you. So here what we're going to do is we're going to create a new data set called DAT-C, dat_C, like cleaned data, right? And then we're going to run this NA-omit command on the whole data set, right? So we're not changing the data, the DAT. We're just going to put all that clean data into a new data set. That way we don't mess up our original data. I mean, you wouldn't anyway, because it's saved as an Excel file. You're never actually doing anything with that Excel file unless you overwrite it on purpose. Okay, so we're going to create this .c, right? Now we're going to check to see that we have no more NAs in our clean data. So we're going to say, is NA.c? Yes. Okay, so now we can look and we sum up the number of NAs in our .c clean data, and there are none, right? They're all 0. Good. So the command worked. Good to check. Okay, now what we're going to do is we're going to look at our original data set and compare with the new clean data frame how many data points we have. So how many observations, question 3, how many observations did we have in the original data frame compared with the new clean data frame, .c, right? So look up here in the upper right-hand corner, you can see our original data set had 344 observations, and our clean data has 333 observations. And if you subtract 333 from 344, we get 11, right? So we have removed just those 11 values or 11 records, right? The rows of data. We removed the whole row of data for those observations that were missing sex, right? It removes the whole row of data. And that's okay. There were 11 we needed to get rid of, but not more, right? Because it could have been that like those ones that were missing sex were different from the ones that were missing bill length. And then we would have removed more. Does that make sense? Okay, great. So how many observations do we have in the original versus the new clean data? I just told you, you can answer this question. I'm not going to type it out. keep this video moving here.